back, guys. Today we are back with another problem, and today's problem is K-Pangrams. So K-Pangrams, and what the K-Panagram basically telling that we will be given a string str and an integer k. We have to return true if the string can be changed into a panagram after k most operations. A panagram is a sentence with containing every letter in the English alphabet. So panagram is a sentence which contains every letter in the English alphabet. So if you see the example, the quick brown fox jumps over the lazy dog. From A to Z, you will be seeing all letters, all letters are present. Okay, that's the reason it has given the answer as true. Okay, and where k is equals to integer k return true in at most k operations. Okay, so after zeroth operation, you are going to see that it is still true. Okay, but what if we have a different example, say triple a, a lot of a's. What you are going to see, we have 25 because we need 25 operations to keep all the letters of English alphabet. So these are the number of missing letters you have to find and check what you have to do. So if the value of this k is suppose say 23, then my answer will be false because I don't have the adequate number of operations required to fulfill my criteria of all the letters of the English alphabets, which is 26. Now let's come example A, B, C, D, E, F, G, H, I, J, K, L, M. Okay, and the value of k is 20. That is saying false. Why? So say for example, if I'm going to take A, B, C, D, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this value shouldn't be 20. It requires 13 operations because 13 plus 13 is equals to 26. Okay, and we are having a 20. So this was the initial problem statement. Now we are going to develop the algorithm for this particular problem statement. The algorithm. Okay, and how we are going to develop the algorithm. So initially we will be having, since it's a Boolean check, we will be having a Boolean function. Okay, and a Boolean function, say function, and this function has a string, and this function also has an integer character, Now my goal is to first convert the string into a lowercase. So I can write s equals to s dot to lowercase. Okay, so I have converted it into a lowercase string. Now what I want is, okay, I need a hash set to store the letters which are present already. So what I'm going to do is hash set. In Python you can have a set, so you can have a hash set of we will have a hash set of character type. So I'm going to just delete this I, make it a character. So hash set of character type. Okay, and the hash set type say present list. So you can write the list as ABC equals to, we can have a new hash set. Okay, after that I'm going to traverse through the letters present in the string. So I can write for int I equals to 0, I less than equals to my string dot length, right? For I equals to 0, and what I can do is I can just simply write but there will be a problem because I am traversing, right? So faster and optimal approach and easier approach will be if I take for say a character counter ch which is present in s dot to char array. So I'm basically converting it into an array, and now I can easily traverse through the elements. Okay. Now my task is if my character, okay, so if character dot is letter, first I'm checking whether it's a letter using the is letter function. I'm going to pass the ch. Okay, if this is true, which I'm assuming it to be true, then I'm going to add abc dot add. I will add the character. Okay, so this is how my loop is completed. After that, say missing. Okay, missing values. So for the missing values, what I'm going to do is 26 minus the size of ABC, because that will give me the total number of elements missing. Okay, finally I'm going to return missing values is less than equals to k. So this was an easy problem using hash set, and I'm going to now execute this particular problem. So how I'm going to execute, you can see it's a code here they are saying. So I will write str equals to str dot to lowercase. Okay, once the str dot to lowercase is being fixed, what I can do is hash set of type character abc equals to new hash set. Okay, now I can have a loop for char ch belongs to str dot to char array. Okay, over here my first task is to, okay, I'm going to check, right? So I'm going to write if character dot is letter the ch, then I'm going to add the ch. Okay, so if this condition is fulfilled, I'm going to add the ch. I'm going to come out of the say missing values equals to 26 minus abc dot size and return missing values less than equals to k. You can compile. Okay, I'm going to submit. Oops, what is the problem? Space and the extra characters that are encountered. So how we can optimize our particular code? So I'm going to quickly go to the submissions. Okay, after going to the submissions, I'm going to check all my submissions. I'm going to view this submission, what I did, and I'm going to copy this, okay, the wrong submission, and paste it over here. Okay, now I'm going to modify the code. How I can modify the code and fix this particular problem and optimize this in a better way. So for that, what I'm going to try to do is, over here you can see guys clearly that we have taken a lowercase array. Okay, we have taken a lowercase array, but now I want to store an array which will have the letter count. Okay, so what I'm going to do is I can have an int letter count. Okay, this is an integer array which will count the instances of the letters. So new int 26 is the maximum amount of letters possible. So once this is done, the way we are adding abc.add, what I'm going to do is I am going to update over here the letter count. Okay, so after abc, what I'm going to do is letter count. Okay, and c. Okay, so letter count is ch minus of the small a plus plus. So this is nothing but it is subtracting the ASCII value from this particular ASCII value of a from this particular instance. Okay, and after that the missing is okay, it's done. Once the missing size is also done, what I'm going to do is after this I'm going to have a counter for extras. So I can have extras equals to zeros. Okay, now here comes the logic. Okay, before returning the missing values, what I am going to do is I'm going to keep a counter. Okay, I'm going to have a loop for int count to letter count. Okay, in this, if my c is greater than 1, that means there are extras. So the extras plus equals to count minus of 1. Okay, count minus of 1. So once the extras are count minus of 1, I will going to have, before returning, I will have an if condition if the missing letters greater than k or extras is lesser than the missing letters. Then I'm going to return false or I'm going to return true. Okay, so how I'm going to write this logic, I have to think over here. Yeah, so over here what I can see is I will have to make a letter array, right? So int letter count equals to new int of size 26. Okay, now I'm going to update over here letter count of c minus of a plus plus. Once this is updated, missing letters is also updated, missing values is also updated. So before returning this, I am going to have a for loop. Okay, before that, int extras equals to 0. In the for loop, what I'm going to do is int c is for counter, present in the letter count array. If the count is greater than 1, then my extras plus equals to c minus 1. So extras plus equals to c minus 1, and the loop is completed. Once the loop is completed, I'm going to have a final if check. If missing values is greater than k, or extras lesser than missing values, I'm going to return false. Okay, I'm going to return false. I'm going to return false. After that, return true. So I'm going to submit this solution and check whether this works or not. Cannot find symbol letter count. Why can't you find the symbol letter count? Letter count. It should find the symbol letter count. Int letter count, I have defined letter count. Okay, so there's a thing, I cannot take this as C, it will be CH. Okay, now I have to compile. Now let's submit. So we have handled the edge cases, and hopefully, yeah, our program is passing all the test cases. So we have successfully completed today's problem statement, and we are looking forward to solve more problem statements. Thank you.